Let's continue with a kind of work in progress. We are starting to investigate what Docker can bring us in terms of improvement in the process of managing ejabberd on a production platform. As you know, we have SaaS platforms. By now, we're using the procedure we used to in order to deploy ejabberd and to upgrade and manage the platform. And Docker offers some very interesting stuff around that. So we started looking at it and playing a bit. That's the subject of this short presentation. Does anyone know what is Docker already? You used maybe? No? Okay. So first I will cover a very simple presentation of what is Docker, how to compare it with other existing stuff, and then how we can get used with Docker to play with ejabberd in a very efficient manner. So Docker is a Linux specific tool. It's written in a Go language. It started close to Paris in .cloud SRL 5 years ago. And 2 years ago, the creator of the technology released the tool as open source license and created what is now Docker Incorporated. So they are based in San Francisco, I guess. And they already developed a lot of partnership with very big players. So it's a big win company, and they are starting to play with very interesting technologies to solve real problems we have today in the cloud world. In few words, it really helps the automation of deployment of your application everywhere, and it helps to reduce a lot of issues we have with dependency, library, etc. So let's go a bit deeper in that. From a high level view, Docker gives you a process in the Linux system. From the Linux host, you see one process running your application. And also Docker brings its own network interface. This is using the low-level call we have now in recent Linux kernel. So it gives a real abstraction of an isolated software environment. This container includes all your libraries down to the libc. So you have everything needed. The only software used outside of the container is the Linux kernel of the host. So, of course, as a direct consequence of that, when you have a container working on your Linux box, it will work exactly the same way on any Linux box. Whatever distribution you have, whatever version of Debian and Ubuntu you have, as long as you have the correct version of Linux kernel running, I think right now it should be 3.10, something like that, you know your container is working correctly the same way everywhere. So if you look deeper, what is Docker about? It's like a very much improved CH root or some kind of BSD jails. From people coming from Freebsd, we will use jails quite often. We include services in jails, and this is very practical. This is something completely absent from the Linux environment, and Docker comes to bring Linux all what we need in order to have this correct isolation for applications. And the good thing with Docker is that we don't need to write custom scripts. We don't need to write development stuff. It's all included in the tool directly. So it's even much more simpler than what jails are under FreeBSD, for example. there is no virtualization, so the Docker, the container, is sharing the kernel with the host system. On the host, you more likely have several containers, they all share the same kernel, but they all have their own resources. You can limit the consumptions to make sure a container does not take the advantage over the another. So as a consequence, you don't need any kind of software emulation. You're just a process in a Linux system. And to play with that, you have a clean API in order to start your container, create the container, push the container, get the container from sub, which like that. And the API also allow you to interact with the kernel without having to play with the low stacks of the Linux kernel. Behind this, you have a Linux container, Alexia, the C groups, and the namespace mainly. The namespace to give you the network isolation, and the container to ensure all your cores are isolated to the container and does not propagate in other environments. This is very important for security. So, container is not a virtual machine. If you push something in a virtual machine, you emulate all the hardware and all the entire operating system. This is heavy. This is more likely not really efficient when you just want to push a web app. Container is just a process. You have no overhead. So when you run the application, when you start your container, it starts instantly. It just brings up the network interface and you're up to go. Inside the container, you have a file system. And this file system is a kind of accumulation of some virtual mounting in isolated images. This allows you to add some stacks inside your container. More likely, you won't package everything in one shot. You will take a base, for example, a minimalist Debian. From this base, you will add your software, maybe just a web application, for example. You will add also dependency libraries, and you may be able to pack this a different way. So if you upgrade your software, you won't necessarily upgrade everything. And in the container you will create from your upgrade, you will just change the small stack, including your app. So we take the same part of the file system that was running in the source container, we put it in the new container and just add the delta to upgrade your container. So this makes improvement of a given container very easy and very practical to play with. And of course, when you start the container from ejabberd, from Linux, you don't have to play with all this. You just start my container version. For example, for ejabberd, I start my container ejabberd 15.10. I don't care about what's inside, it just should work. That's the aim. So the common comparison between the two, you can see on the net is really like this. On virtual machine, you depend on the hypervisor, and also you run the guest OS. All this stack is very heavy. You don't really need this when you want to put application on production. So the container just take your application and binary or libraries requirements. Everything else is job of the tool. Why it's important for us? First, we don't need to launch a complete virtual environment to play with ejabberd. Ejabberd is already kind of virtual machine, by the way, thanks to Erlang Virtual Machine. So we just need some small packages around ejabberd to make it work correctly. And we want that to be very efficient. We don't need an OS. So container, by being very efficient, very fast to start, is a very interesting thing for us. And also, the most important thing is when we build once, we can run it everywhere. If I build a container on my development environment, if I validate it with a test, I can push the same container into production. I'm exactly sure all the binary that have been tested on my development environment are actually running in the production. There is no need to recompile. Also, it's very easy to replicate because Docker comes with a hub. So on a hub, we can share public or private containers. So once you validate your container, you push it on a hub, and you can pull it from everywhere. So when you want to deploy on your infrastructure, it's very straightforward from a server to pull a container and start it. By integrating everything needed and all the libs down to the libc, you can include with your application any low-level optimization you want. That's also interesting because if your server needs some network parameters, some low-level parameters you use to put in the kernel, in a Linux kernel, you don't have to rely on the administrator to apply the parameters for you. You know that inside the container, the network stack is correctly configured. That's important when you have a server with a very high load and you want very low level optimization of the network stack. So of course there are some problems with Docker. It's just working on Linux for now. I'm not aware of plans in short terms to have it working on Windows or natively on macOS. It requires Linux 3.8, and I saw some functionalities at least in 3.10. So I'm not exactly sure what's the required version right now. I think that all depends of the kind of feature you really need inside Docker, but 3.8 is the minimal by now. When we want to push ejabberd on production, of course we have ejabberd bin files, the dependencies, and also the NIF libraries. So we have some Erlang bytecode, we have some dynamic libraries. We also have some configurations. Maybe we have some low-level network optimization. Of course, we have Erlang OTP virtual machine and the dependent libraries. Usually, Erlang is built against libssl, libeb, libpthread also. So that's quite a lot of things. And by now, when we install ejabberd, when we package ejabberd in our installer, we don't put everything. We used to put libssl in order to make sure we can embed the correct version of SSL library inside ejabberd. But of course, we don't include libm, we don't include libpthread, and anyway, we cannot include libc. So at some point, this can raise some problems. For example, a few years ago, they had an incompatibility in upgrade on the libc. So we had to keep an old version of libc for a while until all version of Linux, including Debian stable, was able to upgrade the libc. So when you package a binary product which is just already able to install by itself, you have to keep aware of that. And here we had to wait for Debian to upgrade. So when we use the installer, it has some drawbacks from the container. For example, these problems with libc would not have occurred if we had the container before. So why just bringing ejabberd and erlang by itself is not enough? Actually, when we deploy ejabberd with our installer, we have everything bundled in the installer. That means also the database, the default configuration. For example, we have no way to alter the installer. We have no way for the user to alter the installer and use its own custom configuration at install time. That means for now you have to install ejabberd and then alter the installation with your own configuration and own modifications. That requires a bit of work when you upgrade. Also, we are dependent on libc, and also I'm talking about our installer, but of course ejabberd is deployed with many different ways. We have Debian package, the official one from Debian, but we have also the Debian package we provide. Then the RPM, and the RPM we provide. We have our installer, and we have also some installation from sources. We have the package from Homebrew. Anyway, all this is very complex to cope with, because when someone have an issue, for example, if you don't have the entire context, it's very complex to know where the problem is. Why this does not work? Okay, what version of that? How did you install, etc. This can be very complex to identify the source cause of a given problem. At the opposite, container take care of all this. So when you install ejabberd with container, you know exactly what is running. When you deploy a container, you take your software and you tag it with a given version. So if you install ejabberd 15.10 from the container, I'm 100% sure of what you're running. And that's a real big plus from an admin perspective. You know what is running. And also, when you talk to the dev team is also exactly aware of what is running. So the issue with installation, I just talked about that before. If we don't have technology like Docker container, it's impossible to make sure a given installation is secure, includes the patch you want, etc. Moreover, let's take for example Debian. You know that Debian applies some patches, maybe on Erlang, maybe on ejabberd. Maybe you're not aware of all the patch. So it's very hard to be sure the tag running on the system is exactly the tag you think it is. We tag ejabberd 15.10, but maybe ejabberd 15.10 running on Debian is not exactly the same. Maybe it's just a minor patch in Erlang VM. And of course, when a service is running, install the usual way, we don't have hands on the network stack. So we don't know how the network is configured, and this can bring some problem when the system is going to raise and when we need to scale. So let's say you start from scratch with Docker and you want to write an ejabberd Docker. You want your ejabberd. The most simple thing you can do is to start a Docker from standard Debian JC, for example. Download the installer from ProcessOne, install it with the default settings. apply your configuration, and build your Docker container with that. The Docker documentation is very simple to understand how to build a container, and writing a container like this is just about maybe 20 lines of code, just a description of what base you're taking. Here, Debian JC, what are you doing? wget the installer, run it, copy your configuration file you have made in your host, and package it. But you can also check someone has already contributed in a container which is much more elaborated than just using our own binary installer. In fact, this installer is customizable already and includes some environment you can tweak in order to apply some change without having to rebuild your own container. It has all tags since 14.12, so it's maintained very often and based on Debian JC as well. But it uses Erlang OTP from Debian. The interesting thing is it builds ejabberd from sources. So when the container is created, it just install Debian, install Erlang, install build dependencies, compile ejabberd with all feature enabled, and then package this as a container. So you have a default installation which is able to cope with every configuration possible. So here is an example of the environment you can tweak by now in this container. You can set the Erlang node name, the Erlang cookie. You can define a list of admins and a list of users. So when you will first start the container, it will automatically create and populate the database. You can also, for example, enable or disable the feature of updating contributed modules. You can set the log level, etc. So this is a start, but it's just convenient enough for very base and standard installation. But of course, it's too generic. If you really want to have in production your own ejabberd with your modules, your changes, you have to build your own container. And this is an example of how to do that. Creating your container with your configuration, for example, and your certificate for your server is just as simple as writing this Docker file. So we take the ejabberd container from the hub, we take the last version, we had our configuration, and we had our certificate. We build a new container. So when you start to use your container, it's automatically pre-configured with your service and ready to start without any change. The good stuff is that you don't need any administration task after that. You deploy the container, you start, and it runs. Okay, we didn't talk about storage. On ejabberd, of course, by default, we have the internal database on which we store the users, maybe the offlines, etc. There are two ways to cope with that. The guy who contributed, Raphael, who contributed the container, suggests to use a container data container. In fact, so it's just an empty container with some directory inside. So ejabberd mounts this directory directly and write in it. So the ejabberd container by itself is read-only, and the data container is mounted read-write. But really, personally, I don't think container should be read-write. I think it's very simple to keep container being read-only and just contain runtime but no data. So what Docker brings us, and what is really interesting, is to mount some location from the host file system. So this is really easy to cope with the data after that. And I personally prefer this way. So when you start your Docker, you just tell it to mount some local directory inside the container. This is very useful if you want to upgrade, and that's why we are using Docker container for anyway. We want to have a clean place that just runs software, and we want to upgrade it, but we don't want all the hassle of data migration, backup, restore, etc. So by mounting the database, the logs, and any stuff on the host side, this allows to just plug the new container when we want to upgrade, apply the same configuration, and no need to migration. So that's why using a custom container is very interesting and the way to go for production. You take your configuration, you can also tweak it, and also you can directly integrate ejabberd with your infrastructure. If you have a database and want to link your container directly to your database, it's better to include this link directly into your container instead of plugging the container from the host. Doing so, you just have a ready-to-use container, yes?
If your application that you want to get there has some libraries that conflict with your container, or is built with other libraries, how do you do that? Because if you have a database, it might also be dependent on some lib or some other stuff that I'm dependent on. So how can I then combine those two in the same container?
In this case, you have a container for your database, you have a container for your service, and both containers talk at each other in the same network.
Yeah, okay, but you said you can always integrate, and it's better to put it in the same container.
Not necessary.
Okay, but
not necessary. The idea is to keep one application in one container. So let's take an example on ejabberd. If you want to upgrade ejabberd and have a MySQL backend, you don't necessarily want to upgrade MySQL at the same time. It makes sense to isolate services. So I quickly talked about the hub a bit before, and it's all about how you deploy and share your containers. You can choose public or private storage, but this is very interesting because you can imagine having a private hub inside your corporation. You have a dev team that is building release. When the release is okay for production, they just push the container. Administrator on the server just have to pull them, and it directly starts without any intermediate stuff and any migration scripts needed or anything like that. Also, Docker have some integration with management tools, so it can be integrated very easily in an already running environment. The typical example is your push, pull, run. So I said you have public, private repositories. All the doc is available online and very clean, very clear. So let's take a example with ejabberd, if we take the actual ejabberd container, we can start it giving some values to start. For example, here it say the domain will be example.net. I will create the admin account, and I'm mounting database and logs from the host file system. I'm starting ejabberd 15.9 in a live mode. Of course, each container, when it's available on the store inside the host, can be started, stopped. You can execute command inside. So let's just start it now. Okay, now I should be able to join. Yep. Okay, test one is connected. So here I'm asking Docker to give me status of the server, and oh, this is a demo effect. It crashed. Now I'm still connected. Maybe I'm... No, I'm running. I don't know. Maybe I made a typo on the command. So here I could connect on the debug console of ejabberd inside my container, and I see test one is connected. So just let's try an upgrade. We have the version from September running. Let's upgrade to October's version. So right now we just stop the node and start the new one. Just by quitting the debug console, the whole container will stop. So I already have the last version available, so I just have to start it. I don't have to pull it because it's already done. I have a local store of all images, so when you pull an image once, you don't need to pull again when you want to start it. So I start the new one. I can see it running with the docker ps command, and I should be able to connect. Yep, that's it. Ah, exec. No, I think that's still the demo effect. I don't know why it's...
Maybe that it takes a while to get... I know.
No, the one is another test. No. Anyway, it should work. So, from the administrator point of view, once you're able to pull a container, it's just a matter of stopping the actual one and start the new one. as your team, as your development team, created their own container with your own configuration, your own certificates, and everything like that, and ensuring you share the same file system mount for the database, for logs and everything like that, you know that you have nothing else to do than just start. It really helps to be confident when you upgrade a live system. So yes, no extra change required, no administration task. So if we want to make sure we're able to upgrade and downgrade as well, we miss a bit stuff in ejabberd. By now in ejabberd we're able to automatically upgrade the database schema and the record structure when you upgrade from version N to N+1. But we still don't have the code to roll back. So if we want to take advantages of the container and want to have a rollback button, we miss some code in order to remove some change we have done on the database if we want to cover this. But this is something we can be done. It can be done, I mean. So it also ensures we are able to roll back something that is not correct. So for production, if we want a better upgrade process, we can use a front end, for example, ejabberd. You can use it as a listener and just bind to some internal ports on the host side. So you can play with two nodes, the new one and the old one, and each time you upgrade, you just swap the two nodes. This ensures you don't disconnect all users when you're stopping the old node. Doing so, that all depends on the frequency your users are connecting and disconnecting.
All the containers are on the same host?
In this case, yes.
Same IP address?
Yes, in this case, yes. Yeah. It allows you to start the new container while the old is still running. So user connected to the old one stay on the old one. You have to put the two containers in a cluster. The new user are connecting to the new one, and when you have very few remaining users on the old one, you can just stop it. So the drawbacks is that it,
When they reconnect
on the new one only, because of Asha proxy settings. So doing so is quite good compromise, but it requires you to write script to swap routes and play a bit with ports, mapping, etc. It's not very clean, but it's quite okay. And the simpler thing to perform an upgrade on the cluster is to take use of the cluster properties. So you just start the simple upgrade process, not by one, and using the cluster to balance the user. And you can still, of course, use the load balancer to redirect connections to avoid disconnecting too much user at the same time. Okay, with clusters there is quite small issue anyway. As we say, we need the containers to be linked at each other. And here, in our case, every container will run on different hosts. So we have to attach them correctly so they can talk at each other. There is something called Docker links, but I think this is something that will be outdated somehow in a near future. And it also only link local hosts, local containers, and containers remain isolated. That's a property of the containers also. So we have to use something which is called multi-hosting networking. So this is a settings in Docker to make it link remote containers at each other.
So that's not available right now?
Yes, that's available. There are, in fact, several ways to do that. And I didn't spend enough time to make it clear what is the correct way right now. And also, there is some new stuff coming in a new version, so I'm not quite sure what's the best way today. And also, this multi-hosting networking seems to me to need a new work kernel as well. So it may not be available on every systems. It's based on a key value store that will act as a DNS, in fact. So each Docker will be able to resolve the address of the remote containers. So that's the main problem, because as the container is isolated in its own namespace, you don't necessarily have the view of all the network. And you need to resolve the names somehow. And as you see, you have to create some subnets to connect your containers. I found a simpler solution also. You can create some virtual interface inside your container. I mean, more than one interface, and put a dedicated network namespace for your application. The problem with that approach is that you need to populate the host file inside your container, so each container knows the IP of the other. So this is not something you can deploy dynamically. This is, in fact, not a really good solution. And you also have to have a static naming convention for address. This is not practical. It can work, but it's not good enough for production. It's also possible to use Docker Compose and to play with something which is named DNS Docker. There is a solution with network overlay driver with one of these key value store. There is also another system which is named OneSure. So that's why I said I'm not exactly sure what's the best thing to use now. It seems there is not a very standard and used way to cope with that. And also there is good improvement in the networking stack on the new Docker coming. So we have to read some documentation here. I'm not sure when the new version is coming out, but it will improve things in terms of DNS for the Docker. The aim here is to have one container without any static record of the other nodes, and still keep the ability to resolve names correctly in a kind of virtual internal network for your application. So back to ejabberd container now. There are a wave of improvements. It's just the start. We will work to improve the configuration. First, the aim is just take the stock container, hopefully the official one. We will work in that direction, and just have to set some parameters to have it apply your own configuration, your own cert file, etc. We also want to have its native support of clustering. So that's why we have to balance solutions here and find the best one for this multi-hosting networking. We also want to improve consistency with installation. If you noticed, 2 months ago, we changed the way make install works in ejabberd. We want it to be more compatible with the official Erlang OTP way of installing stuff. That's a lot of work for ejabberd. So we want to put this inside our installer and also inside the container. At the end, we'll have the same kind of installation everywhere. And also, we want to embed our installer with Alexia pre-built, so we don't have to play with an Alexia container in order to combine modules and make stuff work. By now, we have Erlang and Alexia in a binary installer, but if you take the actual ejabberd container, you just have ejabberd, so you forget about the Alexia modules. We will make that happen and make sure it works correctly with Alexia. And also we have a way of improvements to reduce the size of the container. By now it's based on Debian. It takes a few megabytes, and we can downsize this a bit. Okay, do you have some questions about Docker?